Section 7.2 is all about the greatest common factor. We have to be able to find a greatest common factor, then we have to be able to do something called factoring out a greatest common factor. We're going to talk about both of them, but first we have to talk about how to find one. So I'm going to make it very simple as to how to find one, but eventually you need to be able to do it without writing anything down. Sometimes it'll just come to you as to what the greatest common factor is, because it's just such a small number and it's so obvious that's a common factor, but it's not always small and it's not always obvious. So I'm showing you the long way to get it done, and then we're going to have to start trying to do it in our heads. And I'll show you how to do that too. It'll be okay. So the procedure we're going to follow for right now is to find the prime factorization of each term, then any common factors are part of that GCF. So I have two different examples here. This example has two different terms. We're going to find a greatest common factor here. And then this example has two different terms. We're going to find a greatest common factor there. So for here, the first thing I'm supposed to do is write a prime factorization for each of them. So when I go to write this prime factorization, remember we're talking about prime numbers. So the prime numbers for here will end up being 3 times 7. And then I need to break down and list out all of my x's. I'm going to show you every step right now. I'll show you how to shorten it in a minute. Then over here, 28 is 4 times 7, but 4 isn't prime. We said that 4 would have to be broken down. So that's really 2 times 2 times 7. And then times x and y and y and y. Because there were 3 of them. Now, this is what I want to talk about for a second. There's a negative on this. So technically there is a negative down here, but it is not connected to this 2. It's just a negative. So don't think of it as a negative 2. Think of it as just a negative kind of off by itself. It's still part of our term, but it's not necessarily connected to any one part over here. In order for a negative to be part of the GCF, it would have to be in both of these. Since we don't have a negative in both, then that negative is not part of my GCF. So when I'm building my GCF, I look and see what's in both. Do they both have a 3? No. Do they both have a 7? Yes. So I need to make 7 part of my GCF. Then, do they both have an x? Well, yeah. So I need to make that x a part of my GCF. Wait, do they both have 2 x's? No. And they both don't have any y's, so I can't put a y down here either, which means my GCF is just 7 times 7 times x, which is 7x. And that's the GCF. Over here, prime factorization for this is 2 times 3 times x times x times y. And then that one is just 2 x times x times x times y times y. Running off my board. So, when I go to build my GCF, I look at everything individually. 2, yes, there is a 2, so I need to put a 2 down here. Is there a 3? No, because there's no 3 over here. I have 2 x's. Do I have 2 x's over here? Yes. Since I have both x's in both spots, I have to include both x's down here. Now, I have 3 x's over here, but only 2 here, so I can't put 3 down here because I only have 2 here. I've put all the x's that I can. Do I have y's in both? Yes. Only 1 y though, because this one has 2 y's, but this one only has 1. So I can't include but 1 in my GCF. So that's 2x squared y for my GCF there. So now we've talked about how to find a GCF. Now we need to talk about something called factoring out a GCF. This is when the rubber hits the road right here. I'll leave that. We're going to take the problem 16x squared plus 12xy. I'm going to write the steps over here, and then we're going to work out the problem over here. Factoring is like the opposite of multiplying polynomials. So when you factor a polynomial, it's almost like dividing, but it's not exactly like dividing, because the whole point of factoring is for somebody to be able to come behind you and multiply it all back out again. If it was dividing, we would just leave our divisional answer there. But it's not exactly like dividing, because we're leaving them all the information that we have gleaned from that problem so that they can go backwards and multiply and get that answer. So, let's look at this problem. The first thing I need to do to factor out a GCF is to find the GCF that I'm supposed to be factoring out. So we talked before about how you find a GCF, and I said you need to start to be able to do it in your head. So when I look at these two numbers, because that's what I'm finding the GCF of, the 16x squared and the 12xy. When I look at these two numbers, I have to come up with the greatest number that goes into both of those numbers evenly. Well, 2 goes into both of them evenly, but it's not the biggest number. The biggest number is 4. So that means that my GCF is going to have a 4 in it, because 4 goes into both evenly. And then they both have an x, but they both only have one x, because this one doesn't have 2 x's, so I can't say that it's 2. So they both have an x, but they don't both have a y, so I can't include that in my GCF. That makes my GCF 4x. That's it. So now I need to be able to go 16x squared divided by 4x plus 12xy divided by 4x. Now I know we didn't set it up quite like this when we covered these things, but you can still do it because we worked on all of our exponents that way. So 4 goes into 16 how many times? 4. And then 2 minus 1 leaves me with 1x. Plus, because there's a plus there, 4 goes into 12 3 times. Then my x's would cancel out, and I'm left with a y. If I were told to divide, this would be my answer. But they didn't tell me to divide, they told me to factor out a GCF. When they say the word factor, that means we can't lose anything. Everything has to remain in our problem, so everything has to be in our answer. Since I divided to get this, that means I would have to multiply to get back out my original problem. So that's what we want to do. We want to make sure we leave it as a multiplication problem that somebody else could come behind us and multiply this out and get the original. Which they could, because 4x times 4x is 16x squared. And 4x times 3 is 12xy. So this is what our answer is. Make sure you put the GCF outside. Make sure you put some parentheses. That's how you set it up so that it will end up being a product in the end. Because whenever you factor something, it has to be left as a product. Okay, so that's factoring. Let's practice it. Number 13 out of the book says 3pq squared plus 18p squared cubed. They want me to factor out the greatest common factor. So the first thing I'm going to do is write down that my GCF is equal to what? What's the number that goes into both of those evenly? Well, it's 3. And then do they both have a p? Yes. Do they both have more than one? No, that one's only got one of them. Do they both have a q? Yes. Do they both have more than one? No. It only has one of them. Those are the questions you need to ask yourself. What's the largest number? Do they both have that letter? And if they do they have more than one of that letter? So now that we have this, I can set up my problem. Make sure you always put the GCF on the bottom. Here my 3's cancel out, my p's cancel out, and 2 q's cancel out with 1 q, leaving me with just a q on top. Plus, here 3 goes into 18 6 times. 2 minus 1p leaves me with 1p, and then my q's cancel out, so they're gone. But because they asked me to factor out the GCF, that's what makes me put the parentheses and then write my GCF outside. So they could come behind me and multiply it out. Okay, one more. Have to make it just a little bit more difficult, so stick with me for a minute. In order to find the GCF, the questions I was asking is out of the numbers, what's the largest number that goes into both evenly? That's what keeps you from having to write out all the prime factorizations. And then the second question I was asking is out of the letters, the smallest exponent of each letter that is in all the terms. And then step 3 is still divide. So problem number 14 out of the book said 11 j to the 4th k to the 5th minus 13 j to the 3rd k squared. They want us to factor out a GCF. So the first thing we have to do is look at our numbers, because we have to find GCF first. So out of 11 and 13, what number is the largest number that goes into both evenly? Well, it is 1. Because nothing else goes into 11 and 13 but 11 and 13, and that's not the same. So, because they're both prime. So, since it is 1, I don't need to write the 1 because it's understood to be there anyway. So, I'm not even going to bother writing down the 1. But that took care of our numbers. So, out of the letters, if they have, in all the terms, if they have that letter in all the terms, then we need to take the smallest exponent that they have of those letters. So do they both have a J? Yes. What's the smallest exponent? Well, here's 4 and here's 3. So our smallest exponent on J's is 3. So that's going to make my GCF J to the 3rd, because it's the smallest exponent. Now the reason that's the case is that they both have a J. This one has 4 and this one has 3. We need for our GCF to have the absolute most that's in both of them. 4 is more than 3. So they both have to have at least 3, because this one has 3 and this one has even more than 3. But it definitely has 3. So that's why we use our smallest exponent. And then on the K's, since they both have a K, our smallest exponent is 2. So we know this one has 2 and this one has 2. So that's why we can include K squared in finding our GCF. Now usually when I find a GCF, I write it out here to the side so that we know what it is, so that you can kind of remember it. But remember, I told you a while ago that we were going to try to do this all in our head eventually. So I'm going to show you how I do that. Now that you've seen that this is the GCF, when I do it in my upper level classes, I don't write it out at all. I end up writing it. I do write it down, but I end up writing it down here. So we said there was no number, that it was J to the 3rd K squared. And I go ahead and draw my parentheses, so I don't have to rewrite it later. It saves me time later on. Because that's what we were going to do. We were going to write it outside of our parentheses. So now I have it already outside of my parentheses. Now all I have to do is the division. And since it's already written underneath this one, you can kind of see an imaginary division line there. So you could say, I'm going to have 11 left, because 11 over 1 is 11. And then 4 minus the 3 that we took out leaves me with 1 in, and 5 minus the 2 that we take out leaves me with 3 in. And then over here, 13 over 1 is 13. 3 minus the 3 that we take out, well, that's no J's left. 2 minus the 2 that we take out is no K's left. And if you're worried about whether or not you have it right, you can always multiply it out to make sure. You don't have to do it this way, but eventually you're going to want to do it this way. I'd say by next week. it's going to need to be just this quick, just this obvious, just this fast. I think it's kind of easier that way, but I know I've been doing it a long time too, so that helps. Okay, let's talk classwork and homework. Page 276, practice exercises, numbers 21, 25, and 29. And then homework, same page, same practice exercises, numbers 9, 13, 15, 19, 23, 27, and 33. Because we ain't joking about you getting lots of practice in this. You need lots and lots and lots of practice to make sure you remember it. Okay, get to work. Bye.